Good morning, this is Mr. Morales, and I'm going to begin our notes today talking about our final type, or one of our final types of functions for Algebra 1, and that is exponential functions. Exponential functions are basically when you have an equation where x is in the exponent position in an equation. So before we had linear equations, which is something like any number or fraction or decimal times x. Then we did quadratics, where we have x squared in our equation somewhere. And now we're going to move x into the exponent position in an equation. So any number to the x power is considered an exponential function. And these graphs also have very peculiar and interesting types of shapes. So in your calculator, we'll go ahead and begin by graphing y equals 2 to the x power. I'll go ahead and use my calculator to demonstrate. I'm going to go to Scratchpad, to the graphing function. Let me see if I can get my camera to adjust. It is a bit bright. Let's go ahead and get it right in there. There we go, pretty good. So go ahead and graph 2 to the x power. And actually, I'm going to go ahead and zoom in, and I'm wondering if I turn this light off, if that'll make it a little easier to see. Let's try refocusing there. One more time, I do apologize for the delay. There we go, a little better. So let's go ahead and do 2 to the x power. So type in 2, and then to raise anything to the x power, or to any power, you press the button over here next to the x squared. This little arrow pointing up key is called the caret. C-A-R-A-T, I believe. Press that, and that lets you raise anything to whatever power you want. So a little box opens up, type in x, and press enter. And you'll see our exponential curve. That's how it's described commonly. And now go ahead and do Control T, and we'll get our table of values to go ahead and begin our notes. So our notes begin at -2, so I'll go ahead and go to the left, go up 2 units, or actually 3, and there's -2. And I notice already that my numbers start off pretty small. Actually, I would say infinitely small, and then get bigger gradually. So when you have your notes done, your table filled out, and your graph made, I'll go ahead and just show you my notes, and here's the type of graph you get. So from -2, we have a quarter, so you go up a quarter of a square at -2. At -1, you go up half a square. At 0, you're at 1. And then you graph 1, 2, and 2, 4, and you get this nice little curve. Do your best to make the curve, making sure you're including arrows at both ends, because those arrows do indicate very important properties of this function. And we're going to actually describe those properties right now. So when you've completed your table and you've completed your graph, we can go on now to the questions. Our first question is, what is the domain? Our domain is all real numbers. And that is because this graph goes infinitely from left to right. Although the arrow may look like, at least from this perspective, that it goes just straight up, it actually does spread ever so slowly to the right infinitely. If you zoomed out long enough, you would see the graph keeps going more and more and more to the right. It would just be very slow. But it does go forever left, forever right, which is what domain measures. So it's all real numbers. This is my number sign with apostrophe S. What is the range, or the height of this graph? Well, the graph, you can see, gets, if you go from left to right, actually, if you look at it going to the left, looking at it backwards, you see it gets really close to the x-axis, and it looks like it even touches. So let's look at our calculator and our table of values to discover what's really going on here. So I'll go ahead and start scrolling in the reverse order, and I see that I get more and more of a smaller decimal number. And actually, if I go back far enough, even with these advanced calculators, which are basically mini computers, at some point, the calculators can't even show you how small the numbers are getting. They're using scientific notation now to show you how infinitely small these numbers are getting, but they never actually touch the x-axis. So for that reason, the range, we say, is everything greater than 0. We don't say greater than or equal to this time, because this graph really technically never does touch the x-axis or the 0 mark. So it's never equal to 0. It gets infinitely close, but actually never touches. And there's a concept for you to take in, the idea of infinity. Welcome to upper level mathematics. Now, is this function exponential growth or decay? And if you read any graph from left to right, and particularly this one, you'll see that it actually grows from small to big. So growth, that's pretty obvious, I would think. Now here's a new word. What is the horizontal, or left and right, asymptote? Asymptote basically is a boundary. It is a line that your graph gets really close to, but never touches. And graphs can have asymptotes going left and right or straight up and down and in various places. So for this basic example, the asymptote is actually our x-axis right here, because the graph gets really, really close to the x-axis but never touches. So we can say x-axis, or we can also say it is where y equals 0. So we can say either or. It's the x-axis or where y equals 0 if you want an equation. And let's go on to the next question now. We have E. Find the function value of this graph when our x value is 2. Well, if I go over to where x equals 2 on my x-axis, actually, yes, on my x-axis, 1, 2, and I go to where it meets my graph, well, that'd be up here at positive 4. So positive 4 is the value when the x-axis, when my x value is 2, my y value is 4 on this particular graph. Now, what is my x value? That would give me an 8 on the y-axis, or an 8 for an answer. So if I go up to 1, 2, 3, 4, 5, 6, 7, 8, and I move until I actually touch my graph, then I'll go down, and I can see that that is right here, where x equals 3. So my function value, when x is equal to 3, will give me that y value of 8. And my final question is, what is the y-intercept? That is wherever my graph hits the y-axis. And that would be right here at positive 1. So I could say it's at positive 1, or if we wanted coordinates, we could say that would be at 0, 1. Just depends what kind of answer you're being asked to give, in what format, but it's all the same. Now let's go ahead and graph the function f of x equals 1/2 x. You can use your calculator to get the same exact, to get the table of values, similar to like you did before. But now you're going to notice one thing, and is that these table of values seem to go in a reverse order. And that is because whenever you have a fraction or a number smaller, maybe more specific, a number smaller than 1 that's being raised to the x power, then you get the opposite effect of a graph that decreases from left to right. And you see that here. So let's go ahead and answer the same types of questions. And a lot of the answers will be similar. We're asked, what is our domain? The graph still goes forever from left to right, even if it is decreasing. So it's all real numbers, which I'll just go ahead and write out, because you're more likely going to see it in a phrase. But let's get multiple formats in there for our answers. What is the range? For this particular graph, just like above, the range is y is everything greater than 0. This graph is everything but not equal to 0 going on up. Even though when you read it from left to right, it approaches 0, it technically, like we saw in the calculator earlier, never actually hits the 0 mark. It gets infinitely close but never makes contact, so there is no equal sign down here.